Here's problem 23 from the 2016 AMC 8. Two congruent circles are centered at points A and B, and each circle passes through the other's center. The line through A and B is extended to meet the circles at points C and D. The two circles cross at 2 points, one of which is E. What is the degree measure of angle CED? You can pause here and solve the problem before seeing the solution. Let's build the picture. Draw the two equal circles, one centered at A and one centered at B. Each circle passes through the other's center, so the distance AB equals the radius. Let's call that radius R. Now extend the line through A and B until it hits the circles again. It meets the left circle at C and the right circle at D. The circles cross at 2 points. Take the upper one and call it E. Since E is on both circles, the distances EA and EB are each equal to the radius R. Look at triangle ABE. All three sides, AB, EA, and EB, equal R, so the triangle is equilateral. That means angle AEB is 60 degrees. Next, look at triangle CAE. Both CA and EA are radii of the left circle, so they equal R, making the triangle isosceles. The angle at A, angle CAE, is 180 minus 60, which is 120 degrees. The two equal base angles share what's left, so angle CEA is 180 minus 120, all divided by 2, which is 30 degrees. By the same reasoning on the right side, triangle DBE is isosceles and angle BED is also 30 degrees. Finally, angle CED is made of 3 pieces. Angle CEA, plus angle AEB, plus angle BED. That's 30 plus 60 plus 30, which equals 120 degrees. So the measure of angle CED is 120 degrees.